Hey everyone, my name is Dave Sexton. This is the second video in my series of videos on reactive programming. As you can see here, I have Visual Studio open to where we left off in the previous video. And I think I left with a challenge to come up with a specification for this section that I've highlighted here, if the service requires authentication. So I'm going to start in this video by describing how maybe I would define a spec for this section. And then I'll try to quickly after that get right into the code. I apologize, in the previous video I early on said that I was going to jump into the code and then ended up talking about the spec the entire time, but you know, this is not a planned series, so that kind of stuff will happen, but I think it was important anyway to talk about the concepts involved, so I hope that was something useful to some people. And in this video I'll try to spend most of the time coding, but I do want to start off with this part of the spec, at least just describing how I would think about it. So I haven't actually thought about it since the previous video, so let's take a look at it again to refresh my memory. If the service requires authentication, then, well, just to provide a little context here, what happens is if the cancel button is pressed, we deal with cancellation, which I think we implemented here, yes, with cancellations, and then we enable the connect button if the cancellation is successful, right? So this is like essentially if the cancel button wasn't pressed and we didn't go through this flow, and if the connection was established so we didn't go through this flow, then we're here. So during the connection protocol, our application level protocol, if the service requires authentication, then we're going to have to prompt the user to enter a password, and if the server rejects the password, then we'll enable the connect button. Okay. Now, there is some mixture here of business logic and UI logic, right? So I think that's important to identify first. So if the service requires authentication, that's something that we're only going to know about if the server provides that information to the business layer. So this will be some kind of business requirement. In the reactive program, where we had already discussed connecting, the actual side effect of connecting, and I described that as perhaps something that would be better suited for a task rather than an observable. Again, that also remains to be seen. Once I start coding, we'll see what happens, but this is just my initial intuition. And if it turns out that it is supposed to be, or if it does make more sense as a task, then we still need some way of surfacing this service requires authentication rule as input into the system, into this business layer. What's interesting is that input comes from both directions, right? So the business layer is in the middle between, say, a presentation layer and, oh, I remember I messed this up last time. It's actually presentation layer. Between a presentation layer and a service layer or a data access layer or whatever you want to call it. The business layer is sort of sandwiched between the two. So it's going to require input from the presentation layer and from the service layer. And its output will go also to the presentation layer and to the service layer. So it is the glue between the two. That's the way I see it. So for that reason, we have to be able to accept input from the server side as well, which we haven't actually looked at yet. Everything here thus far has been from the presentation layer into the business layer. So I would think of this as another observable. An observable, again, thinking in terms of sequences or streams, if you want to call them streams, it's important because if the service requires authentication, then we'll want a notification of that. But it's possible that the system allows the user to disconnect and then reconnect again later, which may require authentication again. Maybe they want to log in as a different user, for example, or they're kicked out because of a disconnection or something like that. If that happens, then we're going to want another notification that authentication is required. So to me, representing that as a stream makes sense, or as an observable sequence makes sense. Of course, we could also represent all of these asynchronous things as one-off tasks. But then we're going to have to compose the program. We won't be able to compose it nicely. We'll just be writing a lot of imperative code dealing with tasks. In the C# world, we have async await keywords, which make that really nice, but it's still very much how you want the program to behave, because it is imperative rather than what you want the program to do at a higher level of abstraction, which is our goal here with reactive programming, using like a declarative model of programming. And now we have to look at the data type, right? What kind of data type do we want in this observable? If the service requires authentication, there's probably not much useful data that notification could carry, except if there were some rules about authentication or something, or a token or something like that. I think at this point we don't have to worry about any of that. So I'm just going to go with unit again. And we'll, again, enrich the data types as we need to when we actually start building this out. So let's call this, how about authentication? I like something plural usually is better though. So it's not authentications. It's not, well, authentications might be okay. Let's go with that for now. We don't have to waste too much time thinking of proper names. I'll refactor as necessary once we start building the code. So now we have this observable of unit authentications, which essentially, if we subscribe to it in the business layer, will inform the query when the user now needs to enter a password. Now the presentation layer is going to prompt the user to enter a password, right? So as, for example, we didn't do anything in the presentation layer last time, but you may have added something to represent this rule yourself when you solve this problem yourself. But I would put it in the presentation layer, and it should be input into the presentation layer, which is essentially output from the business layer. So we'll need to get some output here. But the input to the presentation layer has to be an observable of unit, I guess, right? Because again, we don't have any real useful information for this authentications observable, at least not yet, right? So this would be authentications similar to that, right? So input into the presentation layer would be authentications coming from the business layer, which would have to be output as well. So, you know, anything that's duplicate here as a getter and a setter will obviously be defined as a single property with a getter and a setter, but I'm just separating them for clarity now, what's input and what's output. In this case, this will serve as both input and output. So the presentation layer will subscribe to this output as its input, and the business layer will be will offer an authentications observable that will be injected from the service layer. Once the service layer provides that observable, we'll have to implement that separately. So what's next? If the server rejects the password, so essentially after the presentation layer prompts the user can enter a password. We could, again, data type wise, we could enrich this with like credential or something like that, network credential class in .NET or something like that. But for now, we'll just go with a string, which is a password. It will be plain text. We're not going to deal with encryption or anything on the client side at the moment. This is not a web application, right? So this is your password that you enter is in memory anyway. If somebody has access to your client application and enough access to scrape memory or to capture key presses, then encrypting the data is not going to do anything, because they'll be able to get to it before you encrypt it anyway, or they'll scrape the memory of the text box or something. Not the text box, because we'll probably use a password box anyway, but they'll scrape the memory once you turn it into a string in order to send it to the server, because we're not going to send the encrypted data to the server. We're going to have to unencrypt it anyway. So we're just going to go with a plain old string here. And then we'll call it passwords, right? And this is output, so this is a getter, because the consumer of this observable will invoke the getter of the property in order to get the password observable so that it can subscribe to it. Notice like this sort of inverse relation here, right? Because the consumer will retrieve the observable reference, then subscribe to it by passing in an observer. So you have the observer going one way and the observable coming out from the other way. So they're sort of like going in opposite directions. Okay, and then if the server rejects the password, so that implies that this passwords observable is going to have to be input into the business layer, right? Not surprising. And then when the business layer receives a password from the presentation layer, it has to send it to the server. Again, I'm going to consider that as just a side effect, a subscription side effect, or something that we'll have to deal with later. Probably makes sense as a task. It's a one-off thing to the server. The server eventually responds back. And if the server rejects the password, we enable the connect button. Otherwise, we just assume that's successful. Now, it doesn't say anything in here about alerting the presentation layer that it was successful, but that's probably important as well. We want to surface that information to the presentation layer so that it can continue with something, but I'm not going to put that in here yet. Again, I don't want to add stuff that we might not actually need. And most of this stuff's probably going to change anyway, to be honest. This is just a high-level view about how to deal with the thought process here. But once we start coding it, you start uncovering some details that are important that you didn't think about maybe, and it changes the design. So this is not going to be a living specification or a living document that I'm going to keep up to date. This is just sort of a learning tool right now. Okay, so we're not going to surface an observable to let the presentation layer know whether the password was rejected or not. There's nothing in the spec for that, and I'm not sure we will need that, even though it seems likely we will want something like that. So we'll just skip that concept. But if the server rejects the password, we do have to enable the connect button, which means that if we look at enable the connect button here, for example, it's the same thing if the connection cannot be established or if the service URL is invalid. And we already have that concept here as part of connection failures. So I don't think I need a separate, server rejected password. I'll just use connection failures, and the string could be server rejected password. Right? So to be clear, we do have to at least let the presentation layer know when the server password is rejected so that it can perform this action. But that's the exact same scenario as this action, and frankly, as these actions as well, right? We want to display any network service or URL validation errors, including password errors in this case. Focus the service URL and select it. That's fine. Maybe the service URL was wrong. In this case, it might be your password was wrong, though. But maybe based on the context, the presentation layer could know which error was which. Actually, that would be a good reason to enhance the connection failures data type, right? So this way, it could be one of two things. It could be a general connection failure, or it could be a password failure, or rather, authentication failure. And being able to distinguish could be useful for the presentation layer, because when it receives an authentication failure, it knows that it's in the middle of the prompting the user state machine, right? It takes the user's username and password. It's in like a pop-up dialog or something, and then pushes it through this passwords observable when the user presses login, like a login button or something. And then the server, let's say, rejects the password, and we push through a new connection failure of type authentication failure. The client can distinguish then between whether it's an authentication failure, and thus it should leave the dialog open but say clear the password and then select the password box, or it's a larger connection failure, in which case it follows the steps up here, right here, if the connection cannot be established. So perhaps having that distinction could be useful, right? And that would be probably the first custom type. Yeah, the first custom type we'd have. So it would be something like, maybe connection failure reason or something like that. And it could be an enum value. So something simple like that. So hopefully you get the idea here. This is a loose kind of way of looking at this. It's just my intuition, my opinion of it, and I'm sure my opinion of this would change also once we start getting into the details of it. And most of the time the changes are not so different from what you see here, but more along the lines of the data types and what kind of data you want to carry back and forth. But I think this is pretty good. this is a good starting point, I think, to actually start writing the code. So I will switch over to the code now, and maybe we'll just follow the spec a little bit for now, just so so I don't have to waste too much time. But at some point, we will definitely diverge from this spec. I'm pretty sure of it. Okay, so where's the code here? We don't have any code yet. So now we have to at least come up with some sort of design, just like a place for the code, the reactive program, that is. So we are in an object-oriented world here, right? Because we're not going to be able to write just a functional program and stick it somewhere. We need to have a type, at the very least, a type and a method, right, where we can invoke that method in order to perform the initialization of the reactive program, and then maybe eventually another method for connecting. So we might want to separate those two things. Often you do on the highest of levels in the application. So because we need some little place to put that stuff, a little type here, I'm going to just start by adding a new class. This is going to be the first type in our program, and I'm just going to call it Reactive Program. Why not? So a lot of times when you're writing like a console app in .NET anyway, the default template in Visual Studio gives you something called Program. So this is just like that, right? It's like our entry point to the program, but this is more specifically our reactive program. Right? And by the way, we're in a portable library here, or net standard library. So there's no dependency on WPF or desktop programming here at all. We're going to try to keep it very abstract, right? Platform agnostic, maybe that's a better way to describe it. Although abstract too. Okay, so now we have our reactive program. We'll make this a public sealed class, and then we have to have a sort of main method here. Let me format the document. And we'll call this, how about main? Why not? That's pretty clear, right? So now we have our reactive program, and oh, you know what? Before we even do that, I have to add references to the RX packages, right? So I'm going to clean this view up a little bit here. Let's get rid of this. Let's move the program up to this view and this one as well. Okay. So now we're going to browse for system.reactive. And you know what? I'm going to grab the pre-release of the latest version, although, pick whichever one makes most sense to you, the latest stable one or latest preview if you're interested in it. The latest preview, I believe, actually has a different surface area, or rather, not API surface area, but the assemblies are different. I think there's only one assembly now, if I remember correctly. So I haven't been totally following along with that evolving discussion, but I'm targeting this one now just because it might be harder to move to this if we target the previous one. So even though this is a preview, I think it's probably stable enough anyway for this video, and at least it will use the assemblies in the shape that they're currently in. So if I have to upgrade in the future, it should be very easy to just allow NuGet to do the upgrading for me automatically. But anyway, not that important. So the reactive program, the reactive framework, the .NET version of it, is actually just a class library, right? So this provides a bunch of extension methods for IObservable and a whole bunch of other things, which we'll get into as we get into them. But suffice it to say, really what it's doing is it's just providing an implementation for IObservable and iObserver so that you don't have to do it yourself, and because it's tricky to get it right if you're trying to satisfy all of the contracts that RX satisfies, which are very important. I mentioned them briefly, I think, in the previous video, but in this video, I think it's probably outside of the scope, but we'll get to it eventually in more depth as we start running into issues that really matter regarding the RX contracts. Okay, so now that we have the package, we can start writing our reactive query. So I'm going to do, oh yeah, I can't do vertical tabs, right? Oh yeah, now I can, because I could just sort of collapse this thing, right? Alright, that's good enough, I think. If I need a little bit more space, I'll maybe open this MD file up as just a regular notepad file or something. A regular text file. Yeah, it's kind of annoying. I wish there was a way to collapse this. There is no way to collapse this, is there? I guess not. Oh, you know what I can do? I can disable. You know what? I don't want to do it. I was going to disable this. It's just an extension I installed, which I really like. I recommend it actually. But I was going to disable it. I don't know what kind of side effects that's going to have. So I'm just going to leave this open. We'll just deal with it as it is for now. And so that was this main spec, and here was the reactive spec. Okay. So let's go ahead and grab these observables, which are inputs, and just paste them here for now. And then I'm just going to add a using statement for this observable interface, and a using statement for unit system.reactive. There we go. And they must have a get accessor, which is fine. So what we're going to do now is figure out which ones also are getters, right? Because I don't want to have duplicates here. So we'll just paste these in. And it looks like authentications is the only one that has a getter and a setter, which is fine. So that's authentications done. And connection failures, we'll just generate. Oh, you know what? I'm not going to generate anything yet because I don't know if we'll actually need it. We'll get to that when we get to it. And we're just going to stick with the business layer for now. Okay. So these setters require us to actually implement the setter in the method. So we have to do it like this. Oh no, we'll have to have a getter also, unless we do it like this, where it's actually expanded, I believe. That's kind of a sad thing. Maybe what it could do is we could cheat a little bit here. I'm going to cheat, and I'm going to make these. Let me grab the ones that aren't getters. So this one is a getter and a setter because it's input and output, right? What we could do is we could actually put these in a separate type called input, so the semantics are clear, even though it's not ideal. Perhaps it's not ideal. So this would be, say, reactive input. And that could be a getter too, because it doesn't really matter. And I'm going to go ahead and create another class in a new file for reactive input. So these have getters on them now, which is fine. But we understand that they're inputs, so they're really just meant to be used as setters. But at least it's a little bit cleaner programmatically. And then we have reactive output. You know what's weird about doing it this way, though? Then you have these weird stragglers here, which are both input and output. I guess I could just separate them. I mean, they don't technically have to be the same observable, right? So let's just do it that way for now. So authentications just goes there with the other reactive input. And then we'll have reactive output, which are actually reactive outputs are just getters. I don't think I need to be consistent with that. I'd prefer to just have everything here anyway, like this. So these will just be getters, and therefore I'll need authentications again here. Okay, I think this is fine. And, oh, I already had these here, I forgot. Okay, so that looks good. Now let's go back to the spec here. So where did we start from? I think we started from connecting to the server, yeah. So the user can set their username before connecting. You know, I don't like having this in a separate file because it's going to be too hard to see. I mean, in a normal app, I would. I'd probably just have 3 vertical panes, but there's just not going to be enough room for that. So you know what? Just for the sake of simplicity in the presentation, I'm just going to move this as a nested class just for now. Maybe we'll move it later. It's nice to have everything here anyway. So when you create the Reactive Program instance, you'll have to set the input. In this case, I think it actually might make more sense as a required field. So it's immutable, right? That way it's essentially read-only. So when you construct Reactive Program, you pass in the input, and we store it here, and it won't change ever again. That's important for us anyway. if the consumer could change the input at any time, we'd probably want to handle that in some way, and I think it would be easier for us to just disallow that. So this is actually a new feature in one of the later versions of C#. I don't know if it's 7 or 6. I don't remember, but this is an anonymous, or rather an automatic property where it automatically puts a field for us, but it also marks it as read-only, which is really nice. Okay, so there's input, and output are getters, which is fine. So our goal really is in the main method to define the outputs in terms of the inputs. If you think of it this way, what good is the program if it has no outputs except for maybe side effects? Side effects in this case are going to be important as well because we're going to be connecting to the server, for example, as a side effect of some input query. So that side effects will be somewhat important, but we could also just look at the program in general, as most programs are, as input and output, and the output is sort of our goal, right? We want to hook up or implement these observables. So because they are getters only, that means they're read only. So essentially they'll have to be defined before main is even invoked, which is fine because we'll have the input already set. So this is actually kind of a nice way of doing it anyway, just having a class injected in, because that means that the class will have to have already been initialized. That will just be our contract here. So that way, after we set the input, we know at this moment we could also start defining the output. The user can set their username before connecting. So that's this observable string of usernames, right? So we could start with the first query, and I'm going to go ahead and use link syntax here. So for now, anyway, we want to have this concept of usernames. Let's just start by just creating a local here, just for the sake of the compiler helping us along here. So we'll call it x's equals from name, or we could say username in usernames. Oh, it's input.usernames. These are not marked as public. That's why I don't have IntelliSense for that. Let me just add those. Usernames, good. Select username. Looks a lot like SQL, right? Okay, so it doesn't like this because we're missing a using statement for system at reactive. It's not giving me any IntelliSense. I'll just type it in myself. System reactive.link. There we go. So it's happy now. So what is X's? X's is, so we know what usernames is. It's an IObservable of string, right? So this query is just taking each string and projecting it. So the output of this query, see, it's just a string for the username variable. So the output of this query is going to be also the same as the input, just an IObservable of string. And we could mouse over var to see that. It's IObservable of out t, and at the bottom you see t is string, right? So it's an IObservable of string. Now, we could change that if we wanted to, which we will in a moment. We could project any other type we want. And there's obviously a whole bunch of other operators we could use, like where for filtering and so on. But I'm not going to talk about this at the operational level. I want to talk about it at the semantic level, right? What exactly are we trying to implement? Again, we'll talk about the operators and what link is and how it works, not in great depth, but at least hopefully enough to make you comfortable seeing it in the video in a future video. So the user must enter a service URL and click a connect button. So the user can set their username before connecting, and they must enter a service URL and then click a connect button. When the username comes in, we don't really have to do anything with it yet, right? We're getting the usernames in. Okay, there's no requirement yet for us to do anything with the usernames, but we need some way of retrieving them. So that's what we have here. Well, retrieve isn't the right word, right? We have some way of subscribing to the presentation layer so that it can push in usernames. If it's a web app, it will just push in usernames from a client browser, right? It doesn't matter. It's a stream, however you look at it. Now, if the user must enter a service URL and click a connect button, again, we'll have something. Yeah, we have something for service URLs, so we could just grab that here also. I'm not saying that there's any rhyme or reason to why I'm doing this yet, other than I'm just sort of creating the queries, and we'll start tying them together based on the business rules as we see a need for it. So from URL in input.service URLs, we'll just select the URL. Compiler's happy. These names, X's and Y's, leave a lot to be desired, but we'll change them at some point as well in the future. Okay, so the user enters their username and service URL, and then they press a connect button. And when that's pressed and the username is valid and the service URL is a valid URI, so to implement this line, we have to perform some validation on the input now when the connect button is pressed. Now, I think there was a couple ways to look at this. I don't remember what I said in the first video, but we could either do the validation when the connect button is pressed or do it when the values come in, because having feedback right away to the interface that some values invalid, for example, could be really useful, right? So maybe what we really want, this is perhaps query number 1 for us, is not just a sequence of usernames, which are the ones that were passed in. We don't even know if they're valid. What we want is a sequence of valid usernames, right? And we're just going to have to project them into valid usernames. And then likewise, we'll want a sequence of valid service URLs, right? And we'll have to figure out how to project those as well. Man, there's not a lot of room here, is there? All right, good enough for now. So I guess I could move these to another line. I don't want to get too ugly in the code either, though. Okay, so we'll go with this for now. So now we have this concept of having a sequence of valid usernames and a sequence of valid service URLs. This is nice because if we could service this as output as well, then the presentation layer could subscribe to invalid username notifications and maybe highlight the box in red and delete the text or whatever, highlight the text, something like that. And also could disable the connect button, right? Because it would know that the connection is going to fail anyway if these aren't valid, for example, right? So it might be nice to actually have these as output as well. So why don't we do that? I don't see why not. IObservable, let's say unit. We don't have to really carry any data. We'll say invalid usernames. Right? The presentation layer already knows what the username is. It was just entered in a text box or something, so we don't need to provide that back again. This would be like invalid service URLs. Right? And now we could say, excuse me, now we need to implement sort of like branching here, right? So we have this sequence of usernames. We need to validate the name and then sort of split it into 2 sequences, right? So we need one sequence to be the valid usernames and one to be the invalid usernames, okay? So this is nice. This is our first query here where we have to do something even a little bit more complicated than just a simple mapping or projection, which is what the select operator does. So we need to sort of do our validation, which is a side effect, and then with the result, split it into 2 separate streams based on what the result is, right? So the way I would do it is you might be tempted to use a where operator here. Let me just show what that would look like, which would be fine, perhaps. I mean, again, a lot of this is subjective. I'm going to show the way that I would like to do it, keeping it, functional, I think. But you do it the way that makes sense to you, and try to learn simpler ways to do things and ways to stay functional and not have to deal with closures or side effects. We want to try to avoid closures and local variables, for example. We're going to stay in the world of the query if we can, to the best of our ability. But things like a where and then writing the query multiple times would potentially work as well. So I'll just show you an example of that first, but I'm going to show you a way that I would prefer to do it afterwards. So if we were to go with just the where operator, which is intuitive, you would say, where is valid username, and then we could generate a method called isValid, right? Now this is a business layer, so this is where I think I like introducing object-oriented programming into the React programming as a supporting role. Like I said from the beginning, we don't want to just slap an isValid method on this class. I mean, we don't want the Reactive program to be this sort of program that has all of the logic in it. Of course not. That's where object-oriented programming really comes in. We could use that to our advantage. It makes our lives a little easier. So let's start out by creating a type here called user. We're in the business layer, so we might as well create it in the business layer because it's a type that can be used throughout the entire application. Service layer, presentation layer, they could all use this user object, for example, right? Or user type, rather. So instances of the type will be objects. So we'll call it user, and now it could have a is valid on it method on it. Actually, what we could do, let me just format this. We'll just say public static user try create. Right? So given a username, we can create the user if it's valid. Otherwise, you'll get a null. Let's say it's a reference type, so we can just return null if it's invalid. So for now, let's just be really silly with this and say it's valid if username equals environment.username, just because that will be the default, and that way it will be valid by default. Environment. Oh, there is no username property because we are in a portable library, and this is not a portable property. So that's okay. I'm just going to hard code something silly for now. We'll say username.length is equal to 5. So only usernames with the length of 5 are valid. And if that's the case, then we're going to return a new user with that name. Otherwise, we'll return null. Right? And then we'll just have to have a constructor here that takes in the username. And we're just going to set username equal to username. And again, read-only back and field will be generated for us. So this is nice and clean. We try to create a user passing in the username. If the length is not 5, if the length is 5, then the new user, then we'll return a new user with that username. Otherwise, we'll return null. And constructing the user with the username sets the username property, which is a read-only field, backing field. Okay, very good. So now we could say try create, user.try create. And we don't want to do that in a where because that requires a Boolean. There's a little trick here. So you could use let, right? We could say let user equal user try create username, and then say where user does not equal null. It's pretty easy to read, right? However, in this case, we don't need the username in scope anymore. So to avoid a closure here, or rather an anonymous type being generated, we could actually use a little trick here. We could say select user try create into user, and that will allow us to continue the query from this point with user in scope, but with username no longer in scope. So it's a little cheaper. The code that the compiler generates for us is a little bit simpler. So, let is a nice operation to use. Sometimes it's very important to use it because you don't want to do something like this. Maybe you do want the variable before it to remain in scope. In this case, we don't. So this is a nice place to use something, this select into pattern, right? So once we get the user, we check to see if it's not null, right? So where user does not equal null means that if the user is null, then we just don't project anything. We just ignore it. Right? That's what the where operator do. It's a filter. And if it's not null, well then we continue. Notice username is not in scope anymore. That's why we're getting the squiggly here. We'll just return the user. So this actually returns the user object now. So these are valid usernames, right? And you might say, okay, well then what are invalid usernames? Invalid usernames, we don't need a local here because we have an output property. We'll create the output property by saying from username and input username, select user try create into this where user equals null, right? And in this case, invalid usernames requires a unit. So instead of selecting the user, right, we could say select unit.default. There is only one unit, and it's the default unit. I explained what this was in the previous video, so I'm not going to explain it again. So invalid usernames is now assigned. Now you might notice a problem with this approach though, which is that we're invoking try create twice, right? We're going to have to invoke it once to see if it's valid, and once again to see if it's invalid. So that seems a little inefficient. Not to mention the fact that even forget about efficiency because we're not worried about performance at the moment. We are worried about side effects, but in this case there are no side effects that we'd have to worry about. The problem here is merely the semantics are weird, right? Why should we have two separate queries to perform validation on a single username notification that arrives? It seems kind of silly to have two separate queries for that. Now we know we're going to have two separate output queries for one being valid, one being invalid. The valid one perhaps is not going to be exposed externally, but we'll be using it internally to build up more rules, implement more rules in the business layer. But one of them will have to be exposed externally. But that splitting could happen after we've already done the logic to determine whether or not the username that was entered is valid or not. So the fact that the validation is being done twice just feels wrong, right? So the way I would do this is I'm going to leave these here for a moment just so we can reference them. I'll just copy. Okay. So what I would do is I would say, let's grab this part again. We'll start from scratch. This is where we were before, right? So we need to, our goal now is to implement this property and this local variable, which we'll end up using internally for other purposes. But we want to share this validation, right? So we'll start with the validation part of it because why not? Obviously, we're going to need to share both of those. Now, username is no longer in scope, so we'll project user. C# compiler is still happy. Now, here's the trick to it, right? We don't want to just project the, well, actually, in this case, it's good. Okay, you know what? So because we created the type, this is actually a little simpler than what I was thinking, but originally I was going to use a tuple, but now we have a discrete type, and we're using null to represent invalid. It's sort of encoded in that, so this makes it a little easier for us anyway. This actually is valid usernames, but it's only really valid if the user is not null, right? So what we really want to do here is we don't want to put a where here yet. We want to actually project the user. In this case, we don't have to have two selects in a row. We could just do it that simply like this, right? So when the username comes in, we select user try create. And either the result is going to be an observable, it's an observable of user, but the result is either going to be an actual user instance or a null value. The null indicates that validation just failed. We don't have the input anymore, but again, we don't care because we're just passing a unit to the presentation layer anyway. So this is actually enough information to implement both valid usernames and invalid usernames. The name here is now wrong. It's no longer necessarily valid. So we'll just call it usernames. Okay. So usernames are actually, in this case, it's not just names either. It's users. There you go. So users are from username and input usernames, select user try create username. Now what we want to do is we want to actually publish this observable. This will allow us to share the subscription side effects. In this case, it's actually a computation side effect, right? The projection is what we're trying to share, but same thing, that's fine. In this case, it works the same way. So publish will take this observable, which was cold, in the sense that every time we subscribe to it, we'll get a new projection, right? And it makes it hot, which means that we can subscribe to it as many times as we want, and there will be no side effects until we call connect. And once we call connect, what you could see is a property, a method on the IConnectableObservable that it was returned. So instead of an iObservable, it's an IConnectableObservable. It's an observable, and it implements iObservable, but also has a connect method. So now we could set up all of our subscriptions, multiple subscriptions, one for valid, one for invalid, as two separate queries. And when we call connect, the publish operator will subscribe to the source. And then any notification that comes in and gets projected will be multicasted to all of the current observers, all current subscriptions. And there will always only ever be two, because that's our, well, that's not necessarily true, because, all right, so internally we'll only ever probably have one subscription to this valid username's local, maybe not, but probably, or this user's local variable. But we may have multiple subscriptions to invalid usernames, right? The presentation layer can subscribe multiple times. That's beyond our control. We don't know. But that's okay, because we're going to ensure that it's that there are no side effects, duplicate side effects, right? That's what the publish operator is doing for us. Now, this is tricky here because we don't want to just call connect right here. If we do that, that defeats the purpose of it. Actually, as a matter of fact, we don't want to call connect at all here. What we want to do instead, and this is a little tricky, but it's important, we're going to actually create this as a private field. We're going to call it iObservable of users, right? And by storing it as a field, remember I said when we first started this that we might want orthogonally to have connect as a separate method in this type, so that the outside program, the consumer, can set up all the observables, set up all the subscriptions, right? Calls all the do all the initialization side effects it needs to do, and then when it's ready, call connect. The purpose of that separation is that connect will be able to connect observables just like this one. So we'll probably have many of these kinds of observables where we don't want side effects to occur until the program's ready. The benefit of that also is that the program now has full control over disconnecting. It just disposes of the disposable that connect returns when it wants to disconnect, and it doesn't have to keep track of every single observer that it's created. So that's very important as well. Okay, so now that we have this user's observable, we definitely don't want to forget to be able to, connect to it. So we're going to create a method called connect that will just, at the moment, just call users.connect. Why doesn't it like that? Because this is actually an IConnectableObservable. Right? It also implements IObservable, but adds the connect method, and that's actually in a different namespace, system reactive subjects. So there we go. And this should be happy now. Yep, users connect, and this returns an iDisposable. So the client will call connect, the presentation layer, right? We'll call connect when it's ready, and then that will set up everything, make the connection to the server. Well, it won't connect to the server until the presentation layer pushes in a username, but the business layer won't react to usernames being pushed in until the presentation layer calls connect, right? And then once the presentation layer wants to disconnect, it would just call dispose on this iDisposable that was returned. Now there's going to be plenty of other observables we're going to want to connect, so we're going to have to deal with multiple disposables and how to compose those, and we'll get into that when we get into that in a subsequent video. Also, very easy stuff here. I'm not doing anything all that crazy or advanced yet. It's just this is a pretty common pattern. I just want to be clear about what we're doing here, but you'll see much more of it in subsequent videos, right? And by the way, this should not be your instinct should not be to publish everything. If you're doing that, you're doing something wrong. I don't want to get into the details of that now, but it's a code smell if you see a lot of publish operators everywhere. It's going to make sense here because specifically we know for a fact we're going to need it. For example, we're just about to make 2 queries over this one, and we want to share this side effect. So there's an actual reason for having publish. If you're just using it because you're not quite sure if you need it, and we're not talking about building a custom operator, we're talking about just somewhere in your code, some type somewhere you're exposing an observable, that's usually the wrong approach. And using operators like ref count as well are usually the wrong approach. But again, I don't want to get into that now. I'll get into that kind of stuff when we get to a point where I think people's intuition might be to go in what I would argue is the wrong direction. So now that we have this user's observable, we can implement valid usernames very easily, right? Valid usernames equals from user in users where user does not equal null. Select user, right? So it's exactly the same as this query, but without this intermediate projection, because that projection's up here. It's going to be shared by both queries, right? So this one's done. And then invalid usernames equals from user in users where user equals null, select unit default, right? And again, this looks exactly like this query, except this part is now shared, right? A little different because of the usernames input, etc., but you get the point. So I'm going to start thinking about what kind of challenge I could leave for you. But let's see here. Okay, so we have users, which is connectable and published, and we're sharing the side effect, and we have valid usernames, which is nice, and we have our first output query defined, invalid usernames. Notice, by the way, this is important, right? This wasn't even in the original spec, and it's the first query we wrote, and that's what I meant. This is the kind of thing that happens. You're not going to get the spec in text terms correct or pseudocode correct. It's just not going to happen. There's just enough details and important factors that you're just probably not going to notice until you actually start coding it. So my recommendation to you is just start coding it like I'm doing here. I probably wouldn't have written the spec up for all these observables. I would have just started coding it by reading this spec, and you would have derived something similar to this anyway. These are probably going to be, valid for us. We'll be using all of these or in some shape or form anyway. but I just wanted to point out that you see that it could change very easily. And in this case, it's not really a change. It's just we added stuff that we didn't even think about in the original video, in the previous video. And there's going to be a lot more of that, I'm sure. Okay, so then we have valid service URLs, and that's similar, right? So that's similar to this one, actually. That maybe is, I don't know if that's too easy of a challenge. I mean, you could pretty much do the exact same thing, right? It's like just changing the names of the variables. But, you know, it's probably a good exercise to do anyway. Maybe I'll leave that as the challenge then. Don't look at this code or delete it or something, and see if you could re-implement it, but do it in terms of the service URLs, right? So remember a couple of things that we want to think about when you're doing this for service URL validation. Is it's not important how you do the validation now, right? That's something we'll implement later because it's not really reactive. It's not a reactive problem. But what's important is that you want to be able to share that side effect, right? Just like we did here. And moving it to another type is obviously one way of doing it. Actually, you know what? That would be an interesting challenge. Let's see if you could do this without creating a separate type for it. So maybe try doing it using, how would you do it using tuple? That's an interesting challenge. That's going to, you know, force you to think in more functional terms, actually, even though it's similar to what we did here. You're not going to have like null as an encoding, right? Think of it as like, think of it as a tuple that represents both the object and the state of whether it's valid or not, right? Something like that. Yeah, so let's do that. To do. Let's say implement valid observables in terms of, let's say, using I think that's a pretty good one. It's pretty simple though. So if you're bored with that one, or if you just think it's too easy, then how about you could also try, let's say, taking in, so when the connect button is pressed and the username is valid and the service URL is a valid URI, we disable the connect button. Well, I guess technically the UI is going to disable the connect button immediately, because why not, right? It's if it gets an invalid error, like invalid username, invalid service URL. Oh, actually, didn't I put this here? Ah, yeah, URL validation errors, service or URL validation errors. So this was part of the query. I think that was part of this connection failures thing. So I instead of having connection failures with a special type here that would say like it was an invalid username or an invalid service URL, I made them into separate types. Okay. The reason why is because it's not, that was the original idea, but the problem was you wouldn't get feedback immediately. Now you get immediate feedback, right? If you enter an invalid service username or service URL, the presentation light will know immediately, and then it could show a red text box like I was saying, right? So that's the difference here. So I'd say we leave that. I think that's good enough. Yeah, there's nothing here that's real complicated though yet. So I wanted to spare you from having to deal with like combining the latest values and performing the side effect. That's maybe too much of a challenge if you're new to reactive programming. So I was going to introduce that in the next video. So let's just stop here. I think that this is good enough. So this will be the challenge if you're interested. And in the next video, I will then implement the service URL and then go to the next step, which is to take the usernames and the service URLs that are valid and combine them in order to create an observable that can then be subscribed to in order to perform a side effect, like actually connecting to a server. And obviously we'll have to have some API for that as well, like how to actually perform the connection, because I want to implement the side effect here. So that will be the next video. And I think that's it for today. So thanks for watching.